And we just got done doing the absolute value where I taught you guys to use a calculator first. This time we're gonna do it manually first, and then I don't know. Sometime I'll go back and do the calculator. All right. So, does anybody know what a quadratic function is? Quadratic function, quadratic equation. We talked about this when we were doing factoring. It's a degree of two. Okay. Do you remember the shape of a quadratic? If I have, say that again, or were you just chit chatting? Huh? Nothing. And just like the absolute value function, it has a parent function. Hasn't come to anybody yet. It's a parabola. It's a U shape, right? U shape. Vertex, the parent function's at 0, 0.
Oh, and he's learned about this in physics or whatever. Parabola and stuff.
Yeah, yeah, parabolas. And in the in the day and age of viruses, I like to call it parabola. Get it? I got one student that got it. In this course, our parabola is either going to open up or it's going to open down. Okay, just like the transformations of the absolute value function that we did. Say we're going to apply all those transformations to the quadratic function. Again, we're going to be doing this all year long. That's why it's imperative that you guys learn those transformations. Now, I was grading the quizzes from the transformations for the absolute values. There's still a couple of you that didn't understand those transformations. If you didn't, please, that is the perfect opportunity for tutoring that to come in after school for that. All right, the parent function is the vertex at 0, 0. By the way, these do have a line of symmetry just like the absolute value functions, right? The line of symmetry is our y-axis or the x-coordinate of the vertex, right? So in this case, it's x equals 0 line, vertical line at x equals 0. That's our line of symmetry. Okay. Let's see, anything else? I think I got everything for that. All right, so the first form we're going to look at is standard form. And again, I mentioned this when we were doing factoring, right? Standard form of a quadratic function is y equals ax squared plus bx plus c. Now this is actually in proper form because we're going from highest degree to lowest degree for the x's, right? X squared, this is x to the first. C, believe it or not, there is an x there. It's just raised to the 0 power, which is 1. That's why we don't normally put that x there for the constant. Now, that makes the A, B, and C, they're coefficients of the x. All of those are coefficients. Okay. And you probably recognize this form the most because in Algebra 1, when you were learning the quadratic equation, you probably had to do like 50, 100 problems using the quadratic equation, right? If you had a really wonderful math teacher. All right, so we talked about that line of symmetry. So the whole point of this is we're graphing these manually. So we need 3 points to graph manually, right? A function. Manually, I should be using the mathematical term to graph algebraically. Bless you. Okay, because that's what we're doing. Algebraically, we're finding our points, and then we graph. All right, so I talked about that line of symmetry. Now, for the parent function, it was the vertex is my x is 0. The parent function is y equals x squared. Okay. Since I have the vertex here, 0, it's really easy to find the x value for the parent function because I just plug in 0 for x and 0 squared, and it gives me y. So the vertex here for the parent function is 0, 0. Now notice that this x gave us the line of symmetry. So in quadratic equations, to get the x coordinate of that line of symmetry, excuse me, we have a formula, and we use those coefficients. Okay? It's negative b over 2a. So that will give me that x coordinate. All right. And then you're probably wondering, well, how do I get the y? Well, just like we did up here, we substitute in that x because we found what that vertex was, what that coordinate was. So we plug it in for x, and then I squared it, and I got the y value. Well, that's what you're going to do after you get the x coordinate. You're going to go back to the equation, plug in that x, and that's going to give you the y. So that's step two. Step two gives you the y value. Step one gave us x value of vertex. So step two is we go back and substitute in that x into the equation to find the y value. Once we have once we have our vertex, we need to find two other points, right? We're going to end up finding our vertex in steps one and two. We have our vertex here, steps one and two. Here's our vertex. We're going to go one bigger. Well, I like to use one bigger. As long as you're bigger than your x value. Okay, so I'm going to go one bigger here, one larger. And then I'm going to go one smaller. And as long as I keep the same distance, like if I go x plus 1 to get the larger number and do x minus 1 to get the smaller one, these y values, these y values will be the same, just like they were with our absolute values functions, right? If you do one larger, one smaller than this number, these will be the same. In fact, that's how we did it on our calculators with the chart, right? To get our 3 points. And I'll do the calculator maybe tomorrow or something. So if I have standard form, I find the x coordinate for the vertex or the line of symmetry. It's nothing more than the x value here. Then to find the y coordinate for the vertex, I go back in and substitute in that x to get the y. Then I find one more point, and as long as I pick that distance the same, all I have to do is find one more point, and I can use it for my third point. Not too bad, right? Vertex form is even easier. Okay, vertex form is easier because if you remember, HK is a vertex from the absolute value function, right? Our HK is the vertex. Now, when you're finding the vertex, remember you have to use the opposite sign of the inside the parentheses, the mathematical symbol. Okay, so if this is minus h, it's positive h. The k is the same sign, just like the absolute value. Our a is still the slope. Okay, remember we had three transformations for the a: reflect, stretch, compress. Three transformations. For the h, left or right, opposite the sign, and the k was up and down. Okay. All right. So we have our vertex here. The only other thing we have to do is find two additional points because we don't need to find the h and the k. So we would make our chart. We get the vertex right from the hk. And then I'm going to do, again, I like to use one larger. You guys can pick whatever number you want, but I highly suggest if you pick like two larger, then go two smaller. Whatever number you pick here, that's what you have to pick here, one smaller. Plug it back. I would take one of these numbers, plug it back into the original equation to get your y. And once you get your y, these are going to be the same. So vertex form is going to be the easiest. Yeah, sure.
Once you get your vertex, after working on the standard form, you're looking for your one lower higher. So in your A spot, if that's a number bigger than one, are you still doing a stretch?
Say that one more time. I just lost the last part of your question.
So yeah, after working off the standard form, you get your vertex, and then you're just waiting for your other 2 points. But in the equation, in the A spot of that equation, if that's bigger than one, are we still stretching? Like in
Right there?
yeah.
Yes. Yeah. Yeah. I it's in such a different form. I didn't do the transformations off the standard form. It's actually a little harder and more involved than that. But yeah, it will tell you the slope. Good observation, Asher. Wow, I've never had a student make that observation. That's awesome. All right, intercept or what we call factored form. Now, you guys probably are not familiar with this. Okay, it's not one of the forms that we use for graphing quadratics because algebra 1 really doesn't go into application problems with quadratics, so they don't really go over factored form a whole lot other than hey, factor the quadratic. That's where it ends. We use it in algebra 2. We go farther because it's very helpful when we start doing our application problems next week. Heads up, right? All right. And again, Asher, you're right. Our A is our slope, and we got the three transformations for that slope, right? Now, the P and the Q, those are our x intercepts. Okay, if you notice, we factored it, right? Remember, we were factoring um, algebraic expressions, and we'd get something like, I don't know, x minus 2 or x plus 3. I'm just pulling numbers out. Okay. Well, this 2 is a p, and this 3 is the q. That's what they're using in the formula. They're using p's and q's. So these p's and q's is where the actual x-intercepts are, or where it crosses the x-axis, right? So if I have a graph here, and suppose I got this parabola, the p and the q are the x-intercepts. That's where it crosses the x-axis. Now, that gives us 2 points. So all we have to do is find the third point. So it's actually kind of nice that it gives us 2 points. But to find the p and the q, we have to take each one of those factors. Like if I took x minus 2, x minus 2, I would have to set it equal to 0 and solve for x. So if I had this problem, my intercept would be positive 2. So what happens is when I have an x minus p, it's the opposite sign of what the p is. So my x-intercept here would be positive 2, and my q would be negative 3, because we have to set that equal to 0 and solve. Yes. But you have to be careful because remember we had some factors that maybe it was like 2x plus 5 times x minus 2, something like that. You got to be careful because it's not just minus 5. You have to set those equal to each 0. So if I set that 2x plus 5 equal to 0, you're going to get a fraction, right? Subtract 5. Then I get 2x equals negative 5. Divide by 2, divide by 2. So x equals negative 5 halves. That's where it would cross my x axis. So simple ones like x minus 2, x plus 3, those are pretty easy to figure out what those x intercepts are. When you have more difficult factors, you're going to have to set it equal to 0 and solve. Okay. Asher, do you have a question?
Yeah, so when you're setting those equal to zero and then switching the sign, like you said, those become your A, B, and C in standard form.
I can't remember. It's been so long since I made comparisons between the two forms. I want to say no, um, but it may not be right. I will look into it and ask and answer you. Okay. All right. So that's how you get your x-intercepts. You set those factors equal to 0. Okay. Now there's a line of symmetry here, right? That goes through that vertex because we need the 3 points to make our parabola. We have two of them with the P and the Q. We need that vertex. To get this x value of the vertex, we use this formula, which is nothing more than taking the average of P and Q. Take these intercepts, add them together, and divide by 2, and that's going to give you x coordinate of the vertex. And of course, to find the y value of the vertex, go back in, substitute in our x, back into the equation, and find y. So, although it sounds complicated, sounds like a lot, it's not that bad. It just we're not familiar with this form too often to graph parabolas. Ready for some examples?
Did you say that substitute x back into the equation to find y, or
The y coordinate of the vertex. Okay, y coordinate of the vertex. Okay. Now I'm going to show you how to do these steps for each form. Okay. Told you it was going to be a long lecture today. All right, huh? Well, I'll give you a homework sheet. Please don't. I always have homework for you guys, don't I? All right. I'll probably tomorrow let you guys work on homework, kind of like a work day or something. Okay. All right. So number one, we're gonna do an example of standard form. So we're gonna use this process to graph a parabola in standard form. Okay. The first thing I like to do is always, when it's in standard form, especially, is state what my coefficients are. Okay. My A is 2. My B, now you have to use a sign with that B, -4, and my C is 3. May not even necessarily use all of them. It's a habit for me. Okay, so step one, find the x value of the vertex using the line of symmetry. So my x coordinate equals -b over 2a. So I have negative, my b is -4 divided by 2 times a, which is 2. Okay, -4 is +4. 2 times 2 is 4. That gives me 1. So my x coordinate for the vertex, I'm going to put my vertex in the middle, is 1.
what did you get to? Like 2 times 2?
It's in our formula. 2 times a. So 2 times my a is 2.
So then times that 2, right?
What's that, Eden?
I'm going to get 4.
Okay. I hear you. Took a while for mine to get going this morning. All right, so that's step one. Step two, substitute that value into the function to find y. Okay, so here's my function. Y equals 2. I'm going to be substituting in for x, so I'm going to put parentheses. -4 times x plus 3. And my x value for the vertex was 1. So I have 1 squared is 1 times 2 is 2. 4 times 1 is 4 plus 3. So my y is going to equal 2 minus 4 is -2 plus 3 +1. Okay. So I'm going to go back and fill in some things here. My vertex, one +1, right? Yeah. Axis of symmetry is the line x equal the x coordinate here. So it's a vertical line at x equal 1. So here's x equal 1. Here's my line of symmetry at x equal 1. Okay. My vertex is 1, 1. So I need to find two more points. I'm going to choose 1 greater than 1, which would be 2, which means if I choose 1 less than 1, which would be 0, my y values will be the same. So I only have to use one, one, one of these points, and I'll have all 3 points, right?
Isn't the y supposed to be negative in
Should it be negative 1?
Yeah.
1 squared is 1 times 2 is 2 minus 4 times 1 is 4 plus 3. 2 minus 4 is negative 2 plus 3 is positive 1.
Oh.
All right, so I'm going to rewrite my, rewrite my function, and I'm going to use 0. You get to choose which one you want. I think 0 is going to be easier. So 2 times x squared minus 4 times x plus 3. And I'm substituting in 0, right? Look what happens. This term cancels out, this term cancels out, and I get y equal 3. I get 3 and 3. Now I can plot those 0, 3, and 2, 3. And here's my parabola. And there I graphed my parabola algebraically, 100% algebraically. Don't you feel good that you didn't use a calculator and your brain did all of that?
No. Doesn't help that much.
Vertex form is pretty easy. Let's do vertex form. Okay, let's do a vertex form. Because we're so familiar with this from the last section, right? Vertex is really easy. It's HK. So I have x minus 4. So my h is positive 4 because it's opposite the sign, my h. My k is the same sign, so it's positive 3. Here's my vertex, 4, 3. So 4, 3 is my vertex. That means I have an axis of symmetry here. Okay. And actually, Asher probably can do the shortcut because he knows the slope is 1 over 1. 1, 1. He can get his 3 points that way. But we're going to go one less. We're going to follow the process chart. 1 less, 3, 1 more, 5, to keep those y values the same, so I only have to do one of them. Y equals, I'm going to substitute my x value in 4 into there, minus 4 squared plus 3. Again, my x value was 4. 4 minus 4 is 0. 0 squared is 0 plus 3, so I know that y equals 3. Um, yeah, something went wrong. Oh, I'm not using 4. I'm using 3. That's what I did wrong. Sorry, guys. 4 was vertex. I should have used 3. So 3 minus 4 is negative 1. Negative 1 squared plus 3. Negative 1 squared is positive 1 plus 3. So my y equals 4. Much better. 4 and 4. Okay. So I got 3, 4, 3, 4, and 5, 4. 5, 4. And there's my parabola. So vertex form is the easiest to graph algebraically, right? And Asher probably cheated because he knew the A was 1, right? The slope. So once he got the vertex, he just went up 1 to the right 1, used the line of symmetry, up 1 to the left 1. All right, lastly, intercept form. It's kind of complicated, but when you put it into action, it's really not that bad. Okay, so first step. First step, you're going to find the zeros. So you're going to set them equal to 0. Now, set each factor equal to 0. So I keep wanting to put that parenthesis. So I have x plus 3 equals 0 and x minus 5 equals 0. So I'm going to subtract 3. So x equal negative 3 and x equal positive 5. And again, you could have probably just went from here to here saying, hey, it's negative 3, positive 5, just use the opposite of signs. But you'll have to do this when you get into more complicated, like fractional ones, right? Axis of symmetry, I have to use this formula. So x equals the average of p, which is p plus q divided by 2. So I have negative 3 plus 5 divided by 2, which is 2 over 2 or 1. So my axis of symmetry is x equal 1. Here's x equal 1. There's my axis of symmetry. We know that the x-intercepts, negative 3, where it crosses the x-axis, negative 3 and 5. Sorry. So my vertex, I know that the x-coordinate is 1. That's my vertex. The x-coordinate is 1. All I have to do is figure out what y is. So I'm going to bring down my equation. Y equals x plus 3 and x minus 5. Going to substitute in 1 for x. 1 plus 3, 1 minus 5. 1 plus 3, 4. 1 minus 5, negative 4. 4 times negative 4, negative 16. So my y coordinate for the vertex, negative 16. Go ahead and plot it. 1, negative 16. And here's my parabola. What's that, Aiden? Any questions, guys? It's just going to take some practice to graph these algebraically. Yeah.
Oh, this kind of
And you're probably saying, hey, can I have the practice sheet so I can have some fun?